Thanks very much for having us. So I've got the great pleasure of being joined by Brad today. So let's kick off. So Brad, could you maybe explain a little bit about your business within Microsoft and what the advantages are for you for migrating to the cloud?
For sure. So our business is processing credit card transactions for Xbox, Office, Azure. As was stated, it's a $25 billion a year business. And as we looked at going toward the cloud, we really wanted that promise of cloud scalability, operational agility, all the simplified deployment buzzwords. But let's put aside all the marketing speak for a moment and really talk about what does it mean to take a high security environment, a highly sensitive environment, because Microsoft isn't the only company in the world that has these types of environments, what we internally called HSEs. Look, these are always the last platforms or products or solutions to move to the cloud or to move to any new platform for that matter. They're always special. These are snowflakes, and they require a lot more planning and risk assessment before we take that leap into something new. Our HSE had been in place since 2016. It survived multiple penetration tests. We were comfortable. We weren't looking for anything to improve on. We had done all the things that we needed to do. So looking at what cloud would offer us started to be tantalizing, started to be interesting, and that operational agility really started to become something that we needed moving forward. Now, it took us 5 years to get from concept to production. Again, HSEs take time. It takes time to go through and plan. And we didn't have all the features that we wanted when we first started that concept planning. Confidential computing was there. So many of the features that our customers use today were there. We could have moved it, but it didn't yet meet our security bar. And so as we looked at features that were dropping from Azure, some of them we influenced the design and deployment of. We constantly adopted new pieces to improve the security bar and our acceptance criteria for moving. That was key and key for us. Now, every other customer that's out there, giving up an environment that you have full and total control over, we managed everything in the data center, the network plane, all the physical assets, all the racks, everything in the data center we own top to bottom. And so moving that was a difficult decision to do, but we knew it could be done. We just had to aim for the right security bar. Now, my colleague Rob Barrice is going to talk about this in a little more detail in his session following us immediately. He's going to talk about some of the operational security things that we implemented as part of this solution. But in terms of value of us going to the cloud, adopting confidential computing, things like managed HSM, that immediately saved us about $2 million in cost avoidance because we were looking at replacing our entire HSM fleet. Now, any of our customers that are out there that manage environments like this, and I've spoken to many of you, you know how expensive and complex it is to deploy physical assets across boundaries, whether they be state or country or geo. It is not trivial to do secure asset transfer in those scenarios. So our deployment times, it would take us maybe 9 months to deploy a new stamp in a new region to get hardware landed, racked, stacked, imaged, everything, all of this, the HSMs deployed and so on. We went from 9 months to days. And so that promise of operational agility was absolutely there. And confidential computing was the linchpin for us to really feel good about the decisions that we were making. And so let's talk about some of the specific objectives that we had in moving and adopting the service.
Great, thank you. So it's really interesting we're talking about that. So, this is a question I come across quite often working with customers who are looking at confidential computing. So, where do you stand as essentially a tenant platform on this?
In terms of, sorry, restate the question.
Yeah, sorry. So, why should you trust the cloud with your confidential data and secrets?
Yes, sure. My quick answer to that when talking to people is you shouldn't trust the cloud for these things. And so why did we do that? Why did we trust the cloud for this? Well, the answer is it takes time and energy and the right selection of products and features and design in order to find the right secure pattern to trust a cloud, regardless of which cloud it is. And so my answer is don't trust the cloud implicitly with any of your data. You need to do the work and adopt the right technologies. Things like confidential computing, things like managed HSM. These are not just platform choices, but they are an integral part in the security baseline that you're going to adopt moving from these highly controlled environments, right? That's really critical. So when we looked at moving the Card Vault into Azure, we had a number of design criteria that we needed to nail. And one of the first ones was, hey, look, there can't be any tricks. Whatever we do as part of this deployment, our customers have to be able to replicate 100% of it. We can't have any hidden features. We can't have any first-party special sauce going on. And so whether you're in the financial services industry or you're just looking at moving highly sensitive cryptography and workloads and AI into the cloud, like we needed to make sure that you could do 100% of that. Then we really looked at like, hey, we know, like we operate in the PCI DSS compliance world. And we knew that the DSS 4.0 standards were coming out. So we needed to make sure that whatever we were doing was going to meet or exceed the future requirements that were going to come down. So even though the DSS doesn't require us to use encrypted memory or protect cardholder data in memory, we wanted to be there influencing that moving forward. So we felt it was a requirement for us, for Microsoft, to trust our data and your data in the cloud, our customers' data in the cloud, to be able to do that. We also wanted to embrace cross-platform containerization. We knew very early on we wanted to aim for standard .NET Core containers. We were very concerned about the development staff and the team that was going to put this together. Retaining talent and attracting talent for these high security workloads is challenging. Let's be honest about that. So we needed to make sure that we weren't so niche that we weren't going to be able to keep people on the team. So embracing that sort of open cross-platform containerization really helped with that. Next, we started our very first conversations with confidential computing team 2018, 2019, just having those statements like, hey, what does a trusted computing base look like? What can we do? What is achievable in the time frame that we have? And that was really, like I said, the linchpin in us trusting that we can have cardholder data in the cloud and that we can trust the cryptography operations that we have to do. We also wanted to make sure that the statement of confidentiality, the fact that we are running in a trusted execution environment, was a deployment time exercise. We didn't want our developers to code to the Open Enclave SDK. We didn't want them to code anything special. Again, standard .NET Core. We can make that decision in our CI/CD pipeline where to deploy. Is it going into a T? Is it not going into a T? That gave us additional operational agility, testing, and so on. And finally, we had to do this in the public cloud. If we did it in a private cloud or a sovereign cloud or a private instance of Azure, we would have failed our objectives there. We had to make sure that you could do it, you could repeat it, you can do it in the public cloud and not require any of that public special sauce. So we proved it's possible. We're willing to take the risk exactly like we're expecting our customers to do. So like I like to think of it as like we have skin in the game, not because we had to, but because our internal trust but verify sort of approach through constant penetration testing, that really gave us the confidence that we were ready for prime time.
Cool. Yeah, and I think that that trust but verify elements, important, particularly with the attestation features that we see in confidential computing. It now kind of marries together what you've done traditionally with penetration testing with actual cryptographic evidence from the platform. Okay, so if we were to think about what sort of precautions you'd need to take to move these sort of workloads, what kind of considerations there are around how safe cryptography in the cloud is. I mean, what are your thoughts in that space?
No, great questions, Simon. The quick answer is take every precaution, take as much time as you need, trust but verify as you're going. If you're running these types of platforms today, you're not going to jump blindly into any solution. You're going to take time to kick the tires. You're going to take time to validate all these assumptions. You're going to come and meet with us and ask lots of probing questions. And that's what we want to be able to do. We want to be able to answer these questions and show you how we did it. And demonstrate that any other customer can do this. So again, Rob's going to cover this in slightly more detail in this presentation. There's a lot of layers in building a secure environment from top to bottom, both in the intra-ID space all the way down into how we protect a lot of these interfaces within Azure. So whether or not you're interested in like PCI DSS compliance, the first order of business is just to aim for a very high bar for security. And ACC, again, it's the linchpin for us for establishing a very small and tight TCB. As everybody on this conference knows, like confidential computing is really key into protecting that data in use. And that was critical for us, protecting cardholder data in use, credit card numbers and sensitive information. That's the statement we really had to underscore for the PCI DSS and our auditors and so on. It's not just secure at rest or in transit. We're applying all of these protections equally through the entire compute layer. The next thing that we had to think about was HSMs are great for doing cryptographic operations. However, the thing that passes the information, the sensitive information to the HSMs, if it's not protected, it's kind of moot, right? That sensitive data is exposed in areas. So we really wanted to combine confidential computing, processing the data in the clear before it hit our managed HSM layer. So it's safe, but the scenario that we ran into was we really wanted to adopt modern standard web protocols and the REST APIs for all the cryptographic operations. Now, the HSM industry itself has adopted some of these REST interfaces, but what we see commonly is the ISVs still only support the legacy PKCS 11 interfaces. And so you have this sort of disparity between those. So my recommendation is when you are moving your workloads to the cloud, when you're building these confidential applications and you're trying to do these cryptographic operations, you do need to take the time to rebuild them using these modern protocols and using these modern interfaces. Otherwise, you're not going to get the same benefits. And so that's a critical lesson that we learned. Is it safe? Absolutely, because the infrastructure and the solution that our managed HSM offering is built on the same Intel SGX solution that our confidential containers are built on. So we get a nice through line between the applications processing confidential data, talking to the managed HSMs, which is also operating in a confidential enclave. So we get very nice consistency and attestation across the entire process. Microsoft has dozens of keys that we use to manage signing and encryption. We dual flighted this across multiple, over multiple months, millions of transactions, comparing the results between what we got on-prem and what we saw in the cloud. And only after we were confident that we always consistently got the right answer, the same answer, that's when we were able to say, hey, we're ready for production. We're ready to move. Let's do it. So, take your time, flight all the changes, and then move when you're ready.
Cool. So I think we are at time. So, Brad, I've lost your audio, unfortunately. But so I think we're at time. But so thanks very much for that. That was really interesting dive into where you've been with your solution, which is really important data, really important platforms.